Did you know that simply changing the thickness of transformer steel can make a transformer cost thousands of dollars more or less in electricity over its lifetime? In the next 2 minutes, I'll explain a common misunderstanding in transformer design. Is thinner electrical steel always better? Most people instinctively say, the thinner the steel, the lower the loss. That's only half true. Let's start with the basics. Inside a transformer core, energy is lost through something called eddy current loss. The thicker the steel sheet, the easier it is for eddy currents to circulate, and the more electricity is wasted as heat. So yes, thinner steel does reduce theoretical core loss. Sounds perfect, right? But here's the problem. When the steel becomes very thin, such as 0.20 millimeters or even 0.18 millimeter, manufacturing suddenly becomes much harder. Sheets deform more easily. Burrs become harder to control. Core stacking stress increases. If the processing quality is not good enough, the real-world loss can actually be worse than thicker material. In other words, you may lose more in production than you save in energy. So how does the industry really choose thickness? Here is the practical range used today for most distribution transformers and export projects. 0.7 millimeter is the sweet spot. It delivers the best balance of low core loss, reasonable material cost, stable manufacturing, and reliable delivery. That's why it is the most widely used thickness in the world today. When should you go thinner to 0.3 millimeter or 0.2 millimeter? Only when the project truly demands it, such as data centers, high electricity price regions, energy subsidy, or ultra-efficiency programs. Transformer steel is not about being as thin as possible, it's about being just thin enough for your efficiency target and your production reality. That's how real performance is achieved. If you need high-quality Kurgo with fast delivery and flexible small batch supply, feel free to reach out to DLS Kurgo.